Hi guys, today I'm going to show you how to calculate the area of some oddly shaped figures that are not rectangles. I have some examples that I've taken from the textbook, and I'll show you a couple of ways to do each one, which is why I have this tracing paper here on top so that I don't actually have to erase my work. I'll start with this example here, figure A. So you can see that this figure is not a rectangle or a square, but it's made up of rectangles or squares. If you think about how you might decompose this figure, one option would be to cut right here and imagine that this is two rectangles. This rectangle would be 2 by 3 units, and this second rectangle on this side is 3 by 6 units. So I can calculate the area of this rectangle. 2 times 3 is 6 square units. And of this rectangle, 3 times 6 is 18 square units. And then add the two together to get the area of the total rectangle, which is 24 square units. Another option would be to decompose in a different way. Try to make that stay down. I could also have cut the rectangle right here, or the figure, right here. So that now I have a 2 by 6, a 2 by 6, giving me a rectangle with an area of 12. And down here at the bottom, I have a 4 by 3, giving me a rectangle with an area of 12 again. And 12 plus 12 is 24 square units. There are other ways I could split this up as well. Those are probably the two most common. Another situation that we sometimes find is where we have a figure with a missing part. So one strategy for calculating this area would be to find the area of the pieces, like we just talked about. So I could split this into maybe a rectangle here. That would be 2 by 6. Maybe another rectangle here. That would be 2 by 4 by 4. And then tall, thin rectangle here. 1 by 4. And this rectangle here, which is 1 by 3. So that has an area of 3. And then add those together. 8 plus 4 is 12. 12 plus 12 is 24. Plus 3 more is an area of 27. Another strategy, probably a more common one and a little simpler, would be to imagine that the figure is solid, is closed in, and calculate as if it were closed in. So this is a 6 by 6. That would make an entire area of 36 square units. But we are missing this chunk here, and I can see that this is a 3 by 3. So the area of this part is 9. So I would subtract the 9 square units that are not filled in. My answer would be still 27 square units. One last type of problem that I want to show you is when we have some angles, lines that are on a diagonal that we're trying to work with. So for example, on this problem, again, I have the large square. It's 6 by 6. So I could calculate that the area of the large square is 36 and then try to calculate this piece and take it out. But because these lines are oblique, they're diagonal, I can't just count like how many units they are. They don't match up perfectly horizontally or vertically like the previous two problems. So one strategy would be to take this this triangle, and imagine that I had rotated it down. I just turned it. It's 2 across, so now this part would be right here, 2. And it's 1, 2, 3, 4 across this way. So down here, 1, 2, 3, 4. And this triangle would fit right in this space next to the blue existing triangle, giving me a rectangle that I can calculate the area of. 2 by 4 is 8. Now this one, I just kind of scribble out. I've already used it, I put it down here. You might recognize that these two triangles are the same size as these two, and therefore I can do the same thing. I could imagine that I had taken this triangle, tilted it down, spun it down, rotated it, and put it right here to make another rectangle that's 2 by 4. So altogether, I have the 8 and the 8. My area here is 16 square units.